should go there, and no cron messages should go there. Auth priv messages, they're all going to VAR Log Secure. These messages, my VAR Log Secure file is empty actually. Auth priv messages are really something to do with, authentication, like somebody logging into the system or trying to get access to the super user account, that kind of stuff, user authentication. But it's private authentication, meaning that if I saw the message, there's some sensitive data even in the error message, and they should go somewhere like VAR Log Secure, somewhere special. Like I said, my VAR Log Secure file is empty, maybe yours is too. These messages are not used very often, okay? But mail messages certainly are, cron messages certainly are, things like that. Two last things. One last thing here is the star.emergency, all right? What that means is that any type of emergency message goes to star. All right. And what star means here is everybody who's logged on the system is going to get an example of that error message. It's going to get a warning of that error message popping up on their screen. Like if one happened right now, it would pop up on my screen right here. Okay? These are not very common, and the reason we just have it as star here is so that everybody on the system sees it, somebody can report it to the system administrator immediately, and we can start to fix it immediately because something is in real danger here on the system. We could, something really important is happening and we should fix it immediately. Okay? One last thing I want to talk about is, look at this like VAR Log Messages file, for instance. All right? So say somebody breaks onto your system. They break into some regular user account like Alice, and then they start trying to figure out what the super user password is. And say they try 20 times, 30 times, 40 times, and eventually they get it. Now they have the super user password. But say they don't really want to use it right now. They want to come back later and gain access later. Maybe like later this week when they figure something else out. Okay, so they've got their way in, but there's going to be messages in VAR Log Messages that say failed super user access, failed super user access, failed super user access over and over and over again. And you, as a system administrator, will be able to see that and say, oh, somebody did that, I better change the super user password, because you'll see that they got in after 20 attempts or whatever. All right? But if they were really clever, what they would have done is they would have logged into the system, they would have tried to get the super user password over and over and over again, and then they got it eventually after 21 tries or whatever. Now what they would do if they were clever is they would go into VAR Log Messages and delete all those unsuccessful attempts, maybe even delete the successful one, okay? And then they would log out. And then they would have the super user password, and there would be no record on the system of them failing to get it. And so as a system administrator, you wouldn't be able to tell that they broke onto your system and got this message or got this information because they covered their tracks by deleting the log files. So what you can do on a networked system, all right, is you can log this information to some remote computer. So here I could use the @ sign like we use an email, like that sign down there. So I could say something like @Adams here. And then what it would do is it would log this information also to VAR Log Messages on the computer Adams. And then that person that broke into this computer would also have to then break into Adams to cover up their tracks, which is going to be a lot harder. They're going to have to go through the whole process, and maybe then Adams is going to log its attempts, failed attempts on some other computer or something like that. Or maybe Adams just only has like one account that even is used, and it's just typically, or it's just a dedicated logging machine. And we had those at an internet company that I worked at, very secure machines that didn't really even have any ways to log into it, and log messages went there, so we could always track down if somebody broke into our system. All right, so that's just a mechanism so that you can log messages to other computers, and it's a more secure way of keeping your log files. Now, another good trick to have in your bag for troubleshooting problems is to know the dmessage command. And the dmessage is what it does is it displays the kernel ring buffer. And the kernel ring buffer is basically just a list of recent kernel messages. So very important messages to your system, or these are the kernel messages. All right? And dmessage, if we hit enter here, a bunch of messages would come up on the screen, and a lot of those messages are already, written to other log files. A lot of them scroll by on your screen when you boot up your system. But dmessage just gives you a way to group them all together and see them all in one shot. right? The stuff that scrolls by on your screen when you boot up your system, you can't really read that stuff. Like even if you had a speed reading course or something, you can read it to the level of detail necessary to really troubleshoot some problem. So dmessage gives you a way to go back and look at those messages. And if I pipe this through more, you'll see the nature of what dmessage outputs, and what you'll probably gain right off the bat is that it's a very, very detailed listing. There's all sorts of information in here. It's telling me what speed my processor is. It thinks how much memory I have available. Information about my caches and how much space I have in my caches. Unbelievable amount of stuff is in here. And if we page down a little bit, here's some information on some drivers. So basically, the messages of in this dmessage output here are information on my system's hardware and the drivers. It tells me what devices the drivers are controlling, whether the drivers were brought up successfully, like here it says bus logic was initialized successfully, that kind of stuff. Okay, so this information is very, very crucial to diagnosing major problems in your system. So this process of troubleshooting a problem on your system has to do with, gathering information, right? We saw how we can look at log files to gather information about, events on our system and when they happened, what kind of things did happen, and so on, and try to put some kind of a timeline behind things and just try to fill in all the missing pieces. Okay, and so any of the system status tools that we've learned so far throughout this video series that can give you some information on that, by all means use them. Remember, for networking stuff, we learned the ifconfig command, and this ifconfig command, if we gave it a network interface, it would tell us all sorts of information about that network interface. The route command, remember, that displayed the IP routing table, and it told us some stuff about what our gateway was, what interface it used to travel to this particular destination, and so on. Okay, so these tools that we've learned before, I don't want to go over them all again in detail, but go back and brush up on those tools, because those tools are really your key to gaining information. The df command and the du command tell you all sorts of stuff about the usage of disk space on your system. There's the fscheck command for checking and repairing your file system, right? There's the lpq command for line printer stuff, so we can see what's in the queue, when it generated, when it started, right? Another very useful command is the top command. Now what top does is it displays information on processes that are running on your system. And now this is kind of like an interactive display, and you'll see it update. There it went. It updates every so often, every 5 or 10 seconds or something, and just displays what are the top resource hogs on your system. Okay, and you can see here the percentage of CPU time that they're using. You can see how much memory they're using, how long they've been running, what their priority is, what user generated them, what user started them up, that kind of stuff. Okay, and also over here on the left is the process identification number that you can use if you want to kill some process because it's hogging your system. So a lot of times, like, troubleshooting problems stem from some process runs out of control. Right? And that process that runs out of control all of a sudden eats up all the memory, and now things don't seem to work right. Well, it's not because your memory cards have come out of your computer or the memory's bad. It's just because some process is out there eating it all up, and maybe it's got some it just won't stop running. It's got some sort of an infinite loop in it, or something that just makes it keep running and keep hogging more and more resources. And you can see here that actually top itself is one of the top hogs of memory and CPU time. Okay, so you don't want to just leave this running all the time, because it'll actually hog up some memory and CPU resources itself. And instead, use it if something's a problem, and then you can get all sorts of information up here, like how much time is being spent by users, how much by the system, how much memory is available, how much memory is used, your swap space. So it's a lot of commands sort of built into one. Okay, you get output from like the df command, you get output from like the ps command, the process status command, and so on. And you can really learn a lot about your system by looking at the top command. And like I said, if you need to kill some process because it's out of control, you quit out of top with a Q, and then what you can do is you could just like kill some process. Remember, use the -9 option to terminate it immediately, and then you could give the process identification number of the process that you want to kill. I don't want to kill any processes, so I'm not actually going to do that for you. Okay, so like I said, any of these system status tools that we've learned so far, by all means, use all of those that you have in at your disposal, all of those that you remember and know how to use well. Use them to gain information about what's going on in your system and what could be the cause of the problem. All right, it's time for a joke. Okay, so 3 people get in a car, an electrical engineer, a chemical engineer, and a computer engineer. Okay, and the car doesn't start. And the electrical engineer says, well, I know all about electronics. I'll go out and fix the car. So he goes out and messes with the batteries and the wires, and the car still doesn't start. The chemical engineer says, well, it must be the fuel and the ratio of the fuel to the air and so on.